Hello dear all students. Today we are going to discuss about the measurement of temperature as temperature measurement in today's industrial environment as well as in human activity become one of the important factor, and to meet this demand industry has developed the wide variety of temperature measuring instruments. So in today's session we are going to discuss about the different methods, instrument and scale used for the measurement of temperature. So let us first discuss about the difference between the heat and temperature. As we know that heat is the one form of energy, whereas temperature is the thermal state of the body. Heat flow from one body to the another body, whereas temperature is the quantity that indicate whether or not and in which direction it will flow. Heat is nothing but the amount of internal energy of the body, whereas temperature is proportional to the average kinetic energy of the molecule of the body. Heat is the cause, whereas temperature is an effect. When there is a difference between the temperature of the two body, then heat flow from a body at high temperature to the body at low temperature. When there is a flow of a heat from one body to the another body, then there will be a increase in the temperature of that body. That's why heat is a cause, whereas temperature is an effect. Heat is measured in terms of joule or kilojoule, whereas temperature is measured in terms of degree Celsius or Kelvin. So this is the basic difference between heat and temperature. Temperature. The accurate measurement of temperature is one of the important parameters across the various industrial as well as human activity, right? Means any human being have the different perception of what is being cold and what is being hot. So let us take one example. Ice cream. We can easily sense that the ice cream is cold, whereas the soup is hot. Means our body can easily sense the change in the temperature of substance. So temperature is nothing but the thermal state of a body which distinguish a hot body from a cold body. So there are the number of methods and different temperature scale are used for the measurement of temperature. International Practical Temperature Scale. For the calibration of thermoelectric instrument, the 7th General Conference on Weight and Measure held in 1927, and they have formulated a convenient scale known as the International Practical Temperature Scale. And this temperature scale is again revised in 13th General Conference that was held in 1968, and in that conference they have defined the fixed point and the reference temperature for the pure substance and ideal gas. And in this conference they have given the three conclusions which state that the triple point represent an equilibrium state between solid, liquid and vapor phase of the substance. Second, normal boiling point is the temperature at which the substance boils at standard atmospheric pressure of 760 mm of Hg or 1.01325 bar. Third conclusion, normal freezing point is the solidification or melting point temperature of the substance at standard atmospheric pressure of 760 mm of Hg or 1.01325 bar. So these are the conclusion made under the 13th General Conference that was held in 1968. Temperature scale. Temperature is measured in terms of degrees by using the different scale. So there are three different types of scale: Fahrenheit scale, Celsius scale and Kelvin scale. And these are the faces behind the invention of these three different types of scale. Anders Celsius, who was Swedish astronomer, physicist and mathematician, has developed the Celsius scale, whereas Daniel Gabriel Fahrenheit, who was the German physicist, inventor and scientific instrument maker, who has developed the Fahrenheit scale. William Thomson, also known as first Baron Kelvin, who was Irish Scottish mathematician, physicist and engineer who had developed the Kelvin scale. Conversion of temperatures. So we can convert the temperature from one scale to the another scale by using this formula. Let us take some example. When we are to convert the temperature from Celsius to the Fahrenheit, then we can use this formula, that is F is equal to 9 by 5 into C plus 32, where this C represent the temperature in degree Celsius. Okay, when you convert the temperature from Fahrenheit to Celsius, then we can use this formula, C is equal to 5 by 9 into F minus 32. So these are the few formulas for the conversion of temperature from one scale to the another scale. Temperature scale. As we have already discussed, there are the three different temperature scale, that is Celsius scale, Fahrenheit scale and Kelvin scale. Now on this temperature scale, let us consider an example of water. Now we know the absolute temperature of water measured on Kelvin scale is 0 Kelvin, whereas the absolute temperature on Celsius scale is minus 273 degrees Celsius, and that same temperature on Fahrenheit scale will be minus 459.7 degree Fahrenheit. We know that water starts freezing, means water gets converted into the ice. On Celsius scale, temperature can be measured 0 degree Celsius, whereas on Fahrenheit scale, that is 32 degree Fahrenheit, whereas in Kelvin scale, that is 273 Kelvin. Our human body temperature on Celsius scale can be measured 37 degree Celsius, on Fahrenheit 98.6 degree Fahrenheit, whereas Kelvin 310 Kelvin. We know that water starts boiling at 100 degrees Celsius on Celsius scale, and the same temperature can be measured with the help of Fahrenheit scale as 212 degree Fahrenheit, and on the Kelvin scale, that is 373 Kelvin. So this is how the temperature can be measured with the help of the different scale. Temperature measuring instruments. Temperature is generally measured by using two different types of instrument, and they are classified as electrical methods and non-electrical methods. So let us first discuss non-electrical methods. In non-electrical methods, the change in volume of a liquid or gas with its temperature can be sensed, and with the help of that we can measure the temperature of any substance or any body. Whereas in electrical methods, we can measure the temperature with the help of thermocouple, or change in the resistance of the material with change in its temperature, or by comparing the colors of filament and object whose temperature is to be find out. So these are the two methods which are generally used for the measurement of temperature, that is non-electrical methods and electrical methods. But there are many instruments which are used for the measurement of temperature in industrial applications. The instrument used for the measurement of ordinary temperature are known as the thermometer, whereas the instrument which are used for the high temperature is known as pyrometer. So these are the few instruments that are used in industrial application for the measurement of temperature: gas filled thermometer, liquid in glass thermometer, mercury in glass thermometer, thermocouple thermometer, and radiation parameter. So these are the few examples with the help of which we can measure the temperature of particular substance or object. So let us discuss one by one. Gas filled thermometer. Gas filled thermometer operates on the principle of ideal Gauss law, which states that the volume of the gas increases with increase in the temperature if pressure remains constant, or pressure of the gas increases with increasing temperature if the volume of a gas remains constant. And that is the ideal gas law, and that is given by PV is equal to RT. This type of thermometer are generally filled with the gases like such as nitrogen, hydrogen, helium, which makes the system more sensitive and to the temperature. Generally, the nitrogen gas is used because nitrogen gas is chemically inert, inexpensive, also has a good coefficient of thermal expansion. So this is the block diagram for the glass field thermometer. So let us see how it works. The glass field thermometer has one sensing bulb, and to that sensing bulb there is one capillary tube, and in this sensing bulb there is one sensitive fluid which senses the change in the temperature of the substance. Now to the end of this capillary tube there is a one elliptical shaped Bourdon tube, and to the end of this elliptical Bourdon tube there is one linkage having the pointer which are calibrated over the scale, and from which we can measure the temperature. So let us see how this works. The temperature of body or object whose temperature is to be measured, that brings in contact with the sensing bulb having the sensitive fluid. As soon as there will be a rise in the temperature of this liquid, this liquid try to expand and move through this capillary tube and enters into this elliptical shape Bourdon tube. And because of the volumetric expansion of this sensitive fluid, this elliptical Bourdon tube get elongated, and because of the expansion of this Bourdon tube, this pointer will move on this calibrated scale from which we can take the reading of the temperature. So this is how the gas field thermometer can be operated. So let us see few characteristics of gas field thermometer. The range of this gas field thermometer, which is it can measure the temperature from minus 268 degrees Celsius to 660 degrees Celsius, and the speed of the response is 4 to 7 seconds. So we can sense the temperature within 4 to 7 seconds of any object or any body. The advantage: greater working range of temperature as minus 268 degrees Celsius to 660 degrees Celsius. Again, no head or elevation effect, means you can use this instrument at any location. Disadvantage is only the larger bulb size is required for the volumetric expansion of gas. Liquid filled thermometer. This type of thermometer are completely filled with the liquid other than the mercury and operates on the same principle as like the gas filled thermometer, and that is the principle of volumetric expansion of liquid. We can increase in the temperature. The filling fluid are usually inert hydrocarbon liquids such as xylene, toluene, alcohol, which has a coefficient of expansion 6 times than the mercury, so that system is highly sensitive. The characteristics of liquid filled thermometer. The range of this means this liquid filled thermometer can measure the temperature from minus 87 to 650 degrees Celsius, and the speed of the response is quite high as compared to the gas filled thermometer because of the coefficient of expansion of liquid, that is the sensing fluid, is 6 times than the mercury, means in 2 to 8 seconds we can measure the temperature of any body. Advantage: wide temperature span, smaller bulb size as compared to the gas filled thermometer, lower cost, and the disadvantage associated with this type of thermometer is compensation of error is difficult and it has the shortest capillary. So this is all about the liquid filled thermometer. Mercury in glass thermometer. Mercury is a liquid. In this respect, a mercury filled thermometer is similar to the liquid filled thermometer. Only the operating, or you can say that sensing liquid is different. Here is, in this case, mercury can be used as a sensing liquid. These two are separated due to the unique characteristics of mercury and its importance as a temperature measuring medium. The range of mercury in glass thermometer: minus 40 degrees Celsius to 649 degrees Celsius. Speed of the response is again quite high. In 2 to 4 seconds we can sense the temperature of any body or object. Advantage: rapid response and high accuracy. So this is the different types of mercury in glass thermometer. I think you have already seen this type of thermometer are generally used for the measurement of any body or object. Thermocouple thermometer. For higher temperature, means more than the 650 degrees Celsius, gas filled or liquid filled thermometers are quite unstable, and for higher temperature measurement, either thermocouple thermometer or pyrometers are used. So this is the block diagram for the thermocouple thermometer, in which it consists of two dissimilar metals or alloys which develop the EMF when the reference or measuring junction are at different temperature. Due to the difference in the temperature of reference junction and the body whose temperature is to be measured, it induces the EMF, and this induced EMF can be calibrated or either on the voltmeter or galvanometer, and from which we can sense the temperature of body whose temperature is to be measured. Generally, the reference junction or cold junction is will maintain at some constant temperature, and that is such as 0 degrees Celsius, or you can maintain the reference junction at any temperature, so that you can measure the temperature of a body from the measuring junction with the help of the EMF induced by these two different metals. So this is what about the thermocouple thermometer. Second is radiation pyrometer, a device which use the device which measures the total intensity of radiation emitted from a body is called as radiation pyrometer. So this is the block diagram for the radiation pyrometer. Now in this, if you want to measure the temperature of this hot object, now in this case the radiation or the intensity of a radiation from this object whose temperature is to be measured is collected, and it is focused on one mirror, and mirror is generally used to focus this radiation on the thermocouple, and this energy which is concentrated on the thermocouple raises its temperature and generates an EMF, and this EMF generated is calibrated in the voltmeter or galvanometer, and from which we can sense the temperature of this hot object. So this is what about the different types of temperature measuring instrument. Generally, the ordinary temperature can be measured with the help of thermometer, and temperature means temperature measured beyond 650 degrees Celsius, either thermocouple or radiation pyrometer are generally used for the measurement of temperature. So I hope you have understand all the temperature measuring instruments, different types of temperature scales and methods used for the measurement of temperature. So thank you for watching this video.